right, so we're recording. This is the beginning of our cluster add-ons meeting, which happens every 2 weeks. If you're joining us in the future from YouTube, greetings, fellow time travelers. This is where we talk about making add-ons more consumable and making better patterns, better UX, better packaging formats. This group has come up with a lot of terrific ideas that I'm excited about. And I think we may have a shorter meeting today because our agenda is not very populated. So, which might be kind of nice given current events. I'm just going to share my screen so that we can all see the meeting notes. If anybody has decided to put any in, feel free to add your name to the attendees list if you desire. And do we have anyone new joining from us? Ilya, I haven't seen you in a while. It's really good to see you.
Hello. I can sort of reintroduce myself. I'm now at Isovalent working on Cilium project, and there are a few things about this group that are relevant to what we do at Cilium.
Cilium is super exciting technology. I'm looking forward to working with you in that context more. And then, everybody else is pretty regular here. So I guess on the Cilium topic, we can just we don't really have an agenda or anything. So we can just ramble and chat for 20 minutes.
Yeah, maybe. Yeah, I haven't quite figured things out. I just thought I'd start joining these meetings again because I have a few things that I need to start looking into, but there are other things that have gotten in my way. So
the major thing that's most interesting to me from an add-ons context with Cilium is, sorry, I'm just going to add some notes here, is that Cilium has a kube proxy replacement that's built into the implementation.
Yeah, that's right. Yeah.
And then obviously it's very configurable CNI, similar, to in terms of configurability and complexity to things like Calico and some of the OVS-based solutions. So configuring that add-on up front, and it's, CNI is totally in the context of the cluster add-on, which is something that, is required, in the bootstrapping process, like needs lifecycle that matches with the cluster at some level. But when I think about the kube proxy replacement feature, that's one of the biggest use cases empathizing with the community and with like third-party vendors and projects that are producing networking solutions that replace kube proxy, and then having kubeadm being this very supported upstream tool that is in practice endorsed by cluster API and that kind of thing. Is there's no way to disable really the installation of kube proxy right now.
Right, and that's one thing. There's a data point though. The kube proxy replacement is only fully functional on newer kernels, so that's the other end of the stack that somehow needs to be brought into the picture. So that's something to think about a bit more as well, right?
Yeah, and then I'll mention that kuberouter as well has an IPVS plus IP tables based one.
Oh yeah.
Yeah.
I'm curious on that kernel question. Is there like a world where you have nodes running different versions and you want to like make the two work together, or do you just want to like not install if you don't have the kernel and say this cluster is?
I guess there could be different scenarios, but it's probably more common for people to have same networking setup on all nodes.
That makes sense. Yeah, I was just curious if that was like a goal or just adding extra complexity that doesn't make sense.
So outside of the kube proxy kind of conundrum, if we're talking about an external system like Cluster API, we also have other challenges when it comes to CNI providers as well, and that's there are certain API server arguments that may be required for a particular CNI, or a particular set of firewall rules that you may need for one CNI versus another. And we get into this weird bootstrapping thing where your choice of CNI, which right now we handle as like a downstream concern, actually impacts the bootstrapping of the cluster, because you have this codependency between these components. So that's something that we're interested in trying to figure out how to solve from the cluster API side. And we would very much like it if a project like Cluster Addons was able to solve it in a way that we would be able to consume both at bootstrapping time, but also after the fact for lifecycle management of these add-ons for the clusters that we're bootstrapping as well.
I'm really interested in what your thoughts are, Jason, on how we could, like, what is the useful layer of abstraction and level of abstraction, like, for solving that coupling?
So I think there's kind of a couple of layers here, and one of those layers needs to involve some type of metadata that would need to be published by the authors of said add-ons to you know, have a way to express kind of these dependencies, like conflicts with you know, kubeproxy or replaces kubeproxy or something like that, in addition to kind of other things like you know, requires, you know, Kubernetes be configured with a pod cider that matches this, or, you know, some way to expose this information in a way that we can consume at bootstrapping time from Cluster API. But then also, you know, the downstream concern of, you know, Cluster API itself not managing these add-ons directly, but managing them through, you know, the Cluster Addons project.
Yeah.
I think we discussed these kind of things, Lee, and so there's kind of two levels of answer, I think. One is that we very much wanted to be able to strip out the hard-coded stuff from places like kubeadm. And then, so that gives you a way to solve the replaces kubeproxy question, because you just have like nothing, or, you know, whatever the absolute minimum is, and then everything's an add-on, including kubeproxy. In my view, several steps up from there, as you get more complexity, is an operator. So, you know, to the extent that there are complicated things to do in managing a network add-on or some other kind of add-on, put that complexity in an operator, and then that's the thing that you install through the kind of YAML for an add-on, and then it figures it out. I mean, my gut feel is things like needs a certain kind of cider or something like that. We're never going to have a generic usable abstraction for things like that.
Yeah, I think the biggest challenge is those chicken and egg type scenarios, because, you know, if we're looking at, like, you know, the bootstrapping scenario for Cluster API and spinning up the initial, you know, cluster, you know, if we don't set it up with the right, you know, pod cider for whatever CNI wants to be deployed, you don't even get to the point where you can deploy the add-on manager, because without CNI, you can't actually deploy any application that's not using, you know, host ports.
Yeah, I'm pretty familiar with installing CNI and thinking about outsiders. I believe I've had the issue open for about 3.5 years that we need to be able to fetch the cluster pod network cider from Kubernetes. But in the context of bringing up a cluster, I mean, I think that can be a top-down thing. The person requesting a cluster can say, here's the cider that should be used, or probably a set of them for IPv6 and so forth. Here's the cider that should be used, and it gets passed down, and it's available at the point of add-on installation. I don't think passing things back up again and trying to negotiate and so on is ever going to fly. This is just my opinion. It's worth whatever you paid for it.
Well, the only reason why I bring that up is because in some cases you need to do that. In other cases, you need to set the, you need to configure the allocate, node cider flags, and there's different things for different CNI providers, especially if you look at flannel configuration versus something like Cilium or Calico, and that the chicken and egg is the difficult part right now, because the answer that we have right now is the onus is on the user to know the 3 different places that they need to set these things so that they don't mess things up.
I've worked in this area for 5 years now, so just pass the information down, and the networks will adapt. Well, maybe not flannel, but it's a lost cause.
Yeah,
so,
I think as a mechanism that does make sense. But yeah, there's certainly the UX consideration. When thinking about cluster API, Kubernetes component config, the COPS configuration, the clusters API from EKS Cuddle, and then combining that with some of these, like we've proposed the add-on installation API, which doesn't need to run from inside the cluster, but could. So from a context of bootstrapping, right, using the same API, right, to get the add-ons into the cluster when there's no CNI is a thing. That was the proposed integration with kubeadm. But composing things like the EKS Cuddle Cluster API or Cluster API itself with the kubeadm component config gives you the bare minimum, like, validated objects that would allow you to specify the same thing in multiple places. That's certainly been kind of my intention or expectation of how the add-on installer would compose with tools like kubeadm. So that you could from the start, say, I'm not using kubeproxy, I'm using Cilium with these flags enabled. I have machines that are of this Kubernetes version, this operating system in this kernel. I'm using kubeadm to bootstrap the API server and scheduler with these arguments. My nodes are annotated in these ways, so they're route reflectors or whatever, right? And there's a lot of the same value being used in multiple places, right? Or values that are related to each other or calculated from each other. But then these objects have to be composed in a similar way that deployments and ingress and service annotations with external DNS or something would need to be composed together. And then oftentimes you're also passing, like in that example, a DNS, fully qualified DNS entry into your application so it can do routing or something. And so as somebody who's working with all of these API objects and composing them together, those fields are duplicated, and it's on you, right, to make sure that it's done right. And that is difficult. So then there are tools in the application space like Helm, which allow you to create abstractions that kind of, like Brian, you were saying, this top-down like approach where you're now feeding that value all the way through these places. Is there either tools in the community that we can use to provide good examples, and maybe even things that are experimentally endorsed, to help people create clusters with complex networking options, is probably the most interesting problem space to me.
So I think the challenge there is if we're trying to, if the goal that we have here is to kind of solve the problem in a generic way that is consumable by the vast majority of users and tools, and you know, trying to dedupe the space that we're in. If we start looking at templating tools and templating languages and things like that, if we get to, if we tie ourselves to one solution in particular, we vastly limit the value to a whole other section of the community. So if we tie our kind of, you know, hitch our wagon to Helm, for example, to solve these problems for us, there's going to be a large part of the community that isn't going to be interested in using Helm to solve those problems.
Yeah, that's certainly been at the, like, that valuing freedom and a level playing field and extensibility has been like the center of our conversation since, you know, early last year from Cluster Addons.
I'm not entirely sure why we are talking about templating and such things in this context. The kind of the more obvious thing that seems like what we should be discussing on this topic is whether there should be a high level capability, like an idea of a high level capability in a cluster. Say core DNS provides the DNS capability. A CNI add-on provides a general network capability, and some CNI add-ons provide a service load balancing capability, and kubeproxy is just a service load balancing capability provider, or something like that. I don't know what's the best language, but so something that would manifest itself in a fairly high level, hopefully simple enough API, where we could, you know, look at a cluster and say, okay, this cluster has a service load balancing capability implemented by kubeproxy, and we're going to go and get rid of kubeproxy and install Cilium instead, and whatever the networking capability provider would be, we could swap that out or work with it. So that's like from Cilium's perspective, right? And from the perspective of supporting a case where a cluster is running already, let's now install Cilium for the purpose of testing Cilium, right?
Just slow down a second. Let's answer the question that you asked. Why are we talking about templating?
Yeah.
Because when we tried to do the simplest possible thing, we found a need to do this kind of IP address plumbing into the config. And so we looked for a solution for that. So I have no argument with your desire to work in higher level abstractions, but we also need to be able to, I think, replicate what we have today. What we thought should be possible is to take the hard-coded config for core DNS and replace it with a soft-coded add-on config for core DNS. We thought that should be possible.
Okay.
We thought that should be the simplest possible thing.
Oh, certainly.
And immediately fell into this trap that you need to do an IP address computation.
Mm-hmm.
So one of the other challenges that we see from the cluster API side is also infrastructure requirements that may be required, especially in the CNI space. So for example, if you use one CNI, you need to ensure that VXLAN traffic is enabled between nodes, or if you use another one, you need to have this port enabled, with this protocol to ensure that things work. And, trying to fit the right infrastructure requirements for the right, CNI provider in particular, but we also can look at other things as well. If we consider things like CSI providers or cloud controller managers in scope as well, those could also introduce IAM requirements between the infrastructure provider and the plugin installed as well. And how do we express those requirements in a way so that we can ensure that those infrastructure requirements are met for the required plugins to stand up a functional cluster.
Yeah, and well, however, the cluster API is much better positioned than kubeadmin, right? Cluster API could actually do something about it. And on the point regarding the ports, I would imagine it should be possible to actually read ports that like a daemon set uses. Obviously, that's a little bit indirect, but you'd probably look at the ports that are actually being declared in the daemon set or whatever the pods are.
Yeah, but that also requires us to kind of introspect the CNI provider and that sort of thing. And that's where I was trying to get into the concept of kind of exposable metadata that we can consume rather instead. That could be in a more kind of versioned and supported format that we can more easily rely on. Because, otherwise we'd have to know whether, this plugin is deployed as a daemon set or a deployment or whatever, and try to introspect across all of those various things, which ties us into kind of doing certain things towards certain implementations, or basically trying to figure out the world somehow generically.
So it's a really great point that you make, Jason, and so this makes me think there's a kind of an N by M matrix of things, cluster API level things that are capable of implementing, like IAM, for instance. So firewall rules, IAM, there's sort of one set of dimensions along that side, and then there's the other set of dimensions about things that either care or do not care, like a CNI plugin or CSI plugin or whatever. And so if I think about it, there's kind of a similar situation in CNI world where we said we're actually not going to put all these things in the spec. We're going to put them in a separate place, which we call conventions. And basically, it's a lot more flexible. People can come along and say, so back in your case, someone can say, well, here's how I want to, here's a kind of a CRD that's going to tell me about IAM requirements. And people on the consuming side can implement that. People on the plugin side can add, let's call them add-ons, why not? Can implement that. There's gonna be what's a good word? Kind of jostling in that space. There's going to be multiple people coming up with comparable requirements, and they're not quite exactly the same. And but yeah, I guess I feel it could it could shake out. You know, there's probably not thousands of these things. There's probably a couple of dozen.
And from my perspective, and this is something that we're trying to enforce in the cluster API space, because we have kind of the core cluster API stuff, which defines kind of the interfaces that individual providers can implement for doing this sort of thing. Anywhere where we can push kind of the definition of a lot of this stuff onto the folks providing the implementation where we can, the better. Because, you know, one, they know, you know, these things better than, you know, somebody working more generically in the space. So they're more easily to be able to be authoritative over these things. But also, you know, just having a way that we can, you know, through contracts, you know, consume that information in core cluster API means we're not kind of hard coding, you know, as much on the core side. And I'd like to see something similar here, so that, you know, it's not on the Addons project to kind of curate this information, where we can kind of defer it off to, you know, the folks who are managing the individual kind of add-ons instead.
Yeah. Let me just find a link for the conventions thing I was talking about. It's not an exact match, but something comparable.
It looks like you're talking, but you're on mute.
My bad. Yeah. Thanks. This idea of exposing metadata for the add-on and relating that metadata to the add-on is interesting to me. Operator framework has done some of that in relation to an operator. There's this challenge that we hit whenever we talk about grouping the actual things that make up the add-on together, and we keep running into this missing idea of packaging. And so like tools have done this to varying degrees, you know, with Git repos, with charts, and we have the OCI packaging KEP that like uses Docker images as transport. Figuring out at an API level, like what the things apply to is interesting enough. Add-on installer configuration also does this. So there's probably some minimum amount of introspection that's necessary from something like Cluster API to dig into the add-on to at least find the metadata custom resource or something that we create. Is that something that you were thinking, like, is that how you would think it would look, Jason, or anybody else from Cluster API?
As long as there's a standardized way, you know, to be able to do that. I don't think we're necessarily picky about what exactly the mechanism is. you know, and so to be clear, you know, is there a centralized component that is going to be managing all add-ons, or are we looking at individual components to manage each add-on in this model? And sorry for my lack of familiarity with
from what we've proposed, the central component is a library and an API.
Okay.
That are just responsible for doing a top-down approach and storing a minimal amount of state about what is applied. And so that allows you to, you know, whenever you invoke the add-on installation library, take the packaging format that's specified and the reference to that package, and then make sure that it's either applied or removed from the cluster.
And how about further lifecycle operations for that add-on?
Our answer for that is if the lifecycle is beyond kubectl apply or delete, and a pre-step of inflating the add-on from the package, then the package should install an operator that deals with the add-on's lifecycle in a declarative way.
Okay, yeah, I'm just thinking about things particularly more like kube proxy that are tied to, you know, the particular version of Kubernetes that you're running in the cluster. Because obviously you have, you know, those ones that are more dependent are going to be more of a challenge on our end to ensure lifecycle is up to date on those than say some that's a little bit more disconnected, like core DNS, for example.
Yeah, where core DNS can run inside of the cluster, you know, like without much help. Although it does need some cluster details.
Well, I'm thinking more along the lines of, you know, the version of core DNS is somewhat disconnected from the version of Kubernetes, and you have a little bit more play there in, you know, version drift and worrying about, you know, updating the life cycle of those components versus something like kube proxy, where, you know, you kind of have to make sure that you're in, you know, at least n-1, you know, for the related Kubernetes cluster.
Yeah, I mentioned I think it should be possible to install kube proxy using the add-on mechanism. I didn't mean therefore that's the way we should always do it. You know, there may be things that are just too complicated. Yeah, I guess I don't know. I'm always trying to get the simplest thing that could possibly work out, and in contact with the real world, where we'll learn much more than we will just trying to think about it. So, so yeah, where there are complications that are not strictly necessary, my instinct is to kind of punt.
Yeah, I mean, upgrading kube proxy from a kubeadm standpoint has been, you know, not the most complicated thing. And so, like, when the cluster, you know, goes through the upgrade, like supporting a new application of the kube proxy daemon set, and then if you want to do something more specific, like target nodes of a particular Kubernetes version, that's certainly within the realm of like a declarative apply.
Well, it gets kind of complicated though, because when we looked at it, we recently tackled this when we started dealing with upgrades with Cluster API. And the way that we're handling it, one, we're not doing a kubeadm upgrade operation because we're trying to keep individual machine instances more, you know, independent. So we're not trying to mutate them after we create them. So we basically stand up a new machine and kubeadm join it to an existing cluster, and that new instance that's joined is the newer Kubernetes version. And what we found we had to do is we basically had to re-implement kind of what kubeadm's doing to upgrade kube proxy at the end of that control plane management. But as we did that, we realized that now if we update that daemon set after we do the control plane, now we're updating that daemon set for all the workers that may not already be, that aren't updated yet. So updating the daemon set at the end of the control plane, you get into the situation to where you're running the newer version of kube proxy than the kubelet that it is running on those worker nodes. And, you know, trying to properly handle that life cycle, we probably should wait until all of the worker nodes for the cluster are also updated before we update that daemon set, to ensure that while it hasn't been an issue to date to run a newer version of kube proxy against the kubelet, it does break kind of the API guarantees that we have.
Did I miss a step? Well, we didn't used to install kube proxy as a daemon set. It used to be a static manifest on the node.
It's a daemon set now.
Whoa.
Yeah.
You need to get out more.
Yeah, I wonder when that change was made, because as long as I can remember, it has been. So that's probably since like at least 1.11.
Yeah.
This makes me smile a little bit.
It's perfectly fine to defer this because kube proxy is like a weird edge case anyway.
I don't think that this is so different from a lot of updating workloads in Kubernetes. There is, I think, a missing link here. What I hear in this upgrade story is that a node local daemon that's supposed to be versioned in relation to the version of the Kubernetes components that are running on it, mainly the kubelet, is not being scheduled in that manner. And we have tools to constrain this. Mainly I'm thinking of node selector and its equivalents. We do not have to have one kube proxy daemon set. And it may be a logical error to think about the upgrade in that manner, in the same way that it is a common logical error to reuse config maps and secrets inside of a deployment's rolling update. Very, very common issue is people try to reuse the same config map, but that actually breaks the semantics of using multiple replica sets that are supposed to point to different versions of a configuration. And the same thing with secrets. When you upgrade a TLS cert on a web server, you supply the old one and the new one, right? And in the same way, if we're trying to support version skew, this is what API machinery and our versioning strategies are for, then we should support scheduling the appropriate versions of kube proxy to the appropriate node pools. Does that sound crazy or logically false to anyone?
I mean, I definitely agree, but you still have lifecycle management challenges around, you know, cleaning up the no longer needed, you know, configs and daemon sets, and, you know, creation of the new ones, you know, in advance of when they're needed.
There's no cost to having like a daemon set with 0 nodes that apply to it. And I think that kind of like desire for cleanliness in the namespace or something is maybe, you know, something that we could look at, but it's certainly not a first order need.
Well, I'm thinking more along the lines of, you know, if you do, you know, taking the kubeproxy example, you would basically have to have a daemon set for every supported version of Kubernetes down to the patch release.
It would be the ones that your cluster has gone through. I don't think that that's unreasonable.
But then you also have other challenges too, related to if somebody's providing kind of custom images and things like that. So there's still kind of this lifecycle management step around, you know, creating these, you know, and I guess you could create them on demand somehow.
Yeah, I think it just the problem that it solves is having multiple daemon sets that are version specific. It's solving the issue of imperative state required during the upgrade. I think if you can solve that problem by using the scheduler, then you are back into declarative land. And then providing custom images up front, cleaning up a namespace when, you know, no machines of a particular version exist anymore. Like, these are things that can happen in the declarative reconciliation loop inside of Cluster API or kubeVM or any cluster management tool. Just getting into CAP territory, which makes me kind of sad. But yeah, I'm not sure if I'm clearly expressing. Hopefully you can see a little bit of where I'm coming from here. But yeah, just to, like what Brian said about like reaching for the simplest thing, it would not be the first time. In fact, we almost have like a pattern of upgrade strategies and bugs and misapplied, you know, logic inside of things like kubeVM for, you know, getting the components to upgrade across a Kubernetes version, being, you know, kind of just enough to make it work. And we certainly could, you know, as like future versions of the tool evolve, like pick a different upgrade strategy. I mean, I think it's fine to question that. To me, it's always made sense that you should have the ability to schedule different versions of kubeproxy or constrain the scheduling of kubeproxy to a particular group of nodes.
Yeah, I agree. And it's actually one of, like, if you look at like the upgrade docs, that's one of the things that's recommended, is to basically run a different daemon set for kubeproxy for each of the versions that are part of the cluster, and using the node selector for that. But that, you know, I'm not too worried necessarily about kubeproxy, but when we start talking about the lifecycle management of various CNI providers and other kind of add-ons, you know, I want to make sure that whatever that, you know, upgrade process is something that, you know, a consumer such as Cluster API doesn't have to know, you know, all of the details about, you know, all of the various supported add-ons that we wish to kind of support, you know, that we would have to codify logic basically to manage the life cycle of all these things, you know, in a different way. You know, anything we can do to kind of formalize that life cycle management helps, you know, that consumption of various, you know, add-ons that the community may produce.
Yeah, certainly the idea of removing something when all of the things that would require it to exist is interesting. But yeah, I think as much as we can encourage a declarative life cycle, we should attempt to coerce the community to produce add-ons that provide solutions that are declarative.
Like, and one of the examples that I like, one of the things that stands out to me is core DNS right now, and the fact that, you know, if you update from one version to another, you may have to update the version of the core file that's being used to feed the config. You know, right now in Cluster API, we're actually, you know, we have that step where we're vendoring the library from core DNS to, you know, inspect the version that we're going from and to, and, you know, converting the config if we need to, and all the mechanics of swapping the config map that feeds into core DNS. All that as part of the upgrade is all kind of hard-coded logic that we have wrapped around the core DNS migration library. And ideally, that's something that we would like to not even have to think about, other than just saying we want to update core DNS from this version to this version as requested by the user.
To me, that sounds a lot like what the core DNS operator should be doing if we're using an operator to manage it as an add-on.
Yeah.
I think that's a really good point. Actually, we've been talking about like packaging add-ons as operators, and you know, we've been looking at the kube declarative, the kube builder declarative pattern that takes a set of YAML files and applies them, but that's often not sufficient to do a declarative update between versions. Like, I think is the point that you're making. I think it's a really important one, and maybe we should talk about that some more.
Yeah, the other bit here that's interesting is the leakiness of API machinery in trying to manage things that do not use API machinery. So core DNS being configured by a core file, not having readily available tools that are integrated into Kubernetes, you know, to deal with the core file and its associated API it ends up, you know, being that if you want to work with an upgrade, then you write a bunch of code and import libraries that you don't feel comfortable importing and owning, you know, into CAPI. And you run into the same problems if you deal with, you know, a TOML file for a load balancer, or, you know, somebody's INI. But it's really interesting to see, like in the Helm space, because they have YAML and the values merging semantics. Like the solution in Helm for this that kind of generically applies is to template the config file and then convert the config, you know, into the values YAML, so that you can do merging and overrides and all that. And then somebody decides to maintain that, hopefully. So it's much better if we can have, I mean, it is a solution, you know, to use an operator that owns that domain. And then basically the operator is exposing the abstraction for you to convert your declaration into what you want done to your config and when that should happen and all that.
I think there's a problem if you don't do something like that, like a core file or a reverse proxy TOML file, I think was the other example.
Yeah.
If you're not managing that via some other interface that an operator translates for you, or something along those lines,
Mm-hmm.
You run into problems where there's an existing configuration and you're updating to the new version, And now someone has to make the decision of which parts of that configuration the user owns and which parts of the configuration the system owns, and can automate it, and like whether it should automatically update or migrate fields or sections, or whether it should give up and say, you've edited some stuff that's, I don't know how to upgrade and you need to resolve this manually, that kind of thing.
Yeah, this makes me think of like when you do an apt update, like dpackage like marks the package as old config, right? Or even if you uninstall it, like if the config was not managed by the package, if the config shells don't match, right, then it says, oh, residual config like left on the disk. And yeah, it's really tricky. I think that there is a lack of practice of like composition. So our core file right now that we ship by default in kubeadm just has the single core file field. But when I've been working with some multi-cluster networking examples, kind of just on my own, and what I found is if you want like multiple systems collaborating on the core file to say configure multi-cluster DNS in a mesh or something, then it's best to break up the core file into different pieces and then like import them and have environment variable overrides and things. So we could do some of that to empower users to be able to, like set the cluster domain, like without the upgrade tool having to know what the cluster domain is and that kind of thing.
I'm not sure I followed that last part. Can you give an example of what you mean?
Yeah, so in let me see. Hopefully you guys can still see the screen. But basically in, what was it? Customize lib, core DNS. Here, I'm using a GitOps approach to override the core file that is produced by kubeadm in order to add an additional import statement. And then the extra zones environment variable is added after cluster local inside of the Kubernetes plugin config. Right? And you could break this up even more with like smaller imports for, the error reload and, health configuration, right? Like that could be imported from a different core file. Same thing for like the metrics thing, could be imported from a different core file. And so this is a very general, default configuration that does work for most people. And then I've kind of decorated it with these additional points of extension so that you can provide a different config map, right, that is optional. So here's a patch for the deployment config, which allows you to specify an optional core DNS config inside of a config map. Right, so this config map doesn't have to exist in order for core DNS to run, but if it does, when the core DNS pod is created, or actually this is managed by a deployment, yeah, so that would always work. Yeah, when the config map is created, it gets mounted, in the config dir, and then core DNS will reload the config. And same thing, I haven't added, and oh yeah, core DNS env, so a separate config map, to override the extra zones. And you could add a system-owned one and a user-owned one.
Right. I think the pattern is a really good example. I think when we start talking about how can we say something, how can we really preserve this property for any add-on? Mm-hmm. I think that's where it gets tricky, because you have this problem even with, we're talking about a core file here, but you have this problem with kube resources as well. How do I know if a field of a particular object is owned by some system component that will overwrite things or reset defaults versus what a user intent is indicating. Like there's some distinction based on whether a field is in a spec versus a status. You know, typically status is system owned and spec is user intent. That's not always true, especially when you start talking about multiple operators interacting with each other, trying to share components, share APIs. You almost need like an ownership model for subsections or fields of Kubernetes APIs.
So there
I
is a
think that
developing,
brings,
but yes. What were you
well, I was
going
going to say, I think that brings to mind a particular pain point that we've seen with implementing stuff with CRDs and trying to persist across what we're calling a pivot, but anytime you have to be able to survive a backup or restore of a CRD-based resource with like a status sub-resource, and that's, you know, sometimes your controller needs to be able to store information that still needs to be persisted across that backup restore. And the only place you can really do that today is in the spec. And that gets into, you know, the ownership model there, because anything in status needs to be completely recreatable.
Yeah, I think, yeah, it's a problem.
But I noticed we're almost out of time, and I wanted to bring up Sedef's cluster API proposal before we completely run out of time, if that's okay.
Yeah, totally.
So I know there is some potential overlap with cluster add-ons work with the proposal as it stands today, but we do also see some value independent of cluster add-ons to still be able to just basically take arbitrary YAML and one-time apply it, you know, at the end of cluster creation. In some cases, there's going to be some things that aren't specifically add-ons, or some things that, you know, don't have a full lifecycle management component to it. And we still kind of want to see that experiment through. But I also want to see, you know, what we can do about getting some more formal integration with the add-ons project kind of spec'd out, and how we can do that kind of in parallel with Sedef's proposal. And then over time, we can look at how we dedupe those things or merge them and that sort of thing for longer term. But the fact that we have the experimental API group and flags now in cluster API means we can do a lot of this experimentation without having to worry about the core cluster API types, and experiment at a more rapid pace with some of this stuff.
Accidentally close the document. But yeah, so I think it sounds like basically you're asking for some shared consensus on, hey, let's go through with this experiment as it stands, and then you're declaring, you're just explicitly staying still interested in the long-term composition of add-ons work with post apply.
Yep, exactly.
Yeah. Yeah, I'm certainly not interested in blocking anybody from making progress on seeing how cluster API can create usable clusters. And what's the most appropriate way to, or the best way to communicate about how to put these things together? Like, do you guys want to see like an enhancement proposal? Do you want like just comments on the post apply stuff, or a PR?
So I think we have two different routes that we can take. We can either take, you know, a proposal-based approach, or we can take a POC-based approach. And if we go the proposal-based approach, I think we probably just need to get, some time together between somebody from that's familiar with the Cluster API project with somebody who's more familiar with the add-ons work, and see what we can do to kind of hash out that proposal. Or we can just go ahead and go POC phase with it, which I think it depends on whoever we get involved, both from the Cluster API side and in the add-on side. I'm fine with either approach, and I think whichever way works best for the contributors, I think.
Cool. I mean, I'm the only person who's contributed actual code to the install config thing, and it's really not that complicated. So I'd be happy to just write a POC that kind of fuses with Sedef's work. If that's all right with you, Sedef, I don't want to mutate your thing beyond recognition. So.
I think, yeah, that works. POC way is what I would prefer to see how it combines together.
Okay, cool. Yeah, I've been wanting to play with the post-apply config. It's like the next step on this multi-cluster networking thing that I was working on. I wanted to see what it would look like to use like a post-apply config, like a new one, just like try and upgrade a component. Because my mental model of how that converges when there's a cluster seems to think that there's some creative ways to use it. So, yeah, I know we're running out of time already. We're over. So, but yeah, if you'd be fine to read a POC and you have the bandwidth to do so, I'm happy to submit something. Thanks for bringing it up, Jason, and to both of you for joining.
Thank you.
Okay, I'll mark that action item is +3 for POC to Cluster API post supply for add-ons integration. Cool. And then I still need to talk to Justin about COPS, but great. Does anyone else have anything that they need to bring up? We're a little over, so.
If you want, I can meet up with you at some point later, Lee, and go through kind of the stuff that we're doing today around core DNS and kubeproxy for lifecycle management with Cluster API as well.
That would be very helpful for me if you would so kindly take the time. Do you want to just send me an email or ping me on the Slack?
Yeah, I'll reach out to you in Slack and schedule some time.
Okay. Thanks, Jason.
Yeah.
Cool. Well, thanks everyone for a wonderful discussion today. Thought we were going to have a short meeting, but as usual, everyone's just too dang smart. So I'll see you guys in 2 weeks and even before then.
Thanks. Bye, everyone.
Bye, everyone.
Thanks all.
Bye.